All right, just a quick video here. You know what, as I went through your homework on page 916 and 917, gosh, it's such a train wreck. So I'm going to go through a couple of problems with you, and what you guys are missing is you were fine when the problems were pretty easy, and then when the problems require you to do factoring, you have forgotten how to factor. And so factoring is things like slide and divide, or factoring out the greatest common factor. And that's really useful for a lot of these problems. Now, I will tell you what makes this particular problem difficult is that this is a sine and this is a cosine. So you know what I would like them all to be the same. So what I'm going to do is I can actually work with this. You can recall that you needed to memorize that sine squared theta plus cosine squared theta equaled 1, right? So if I subtract cosine squared theta from both sides, I get sine squared theta equals 1 minus cosine squared theta. Agree? So this is just from our earlier section on trigonometry. So what I'm going to do is I'm going to plug this and place the sine squared theta right here. So 2 times 1 minus cosine squared theta. And here's another thing before I continue. Good grief, folks. You can't not put the theta. I cannot tell you how many homeworks I'm looking at where you just have sine squared and cosine. You have no theta. Sine and cosine aren't variables. They are things to do. So when we take the sine of theta, it is saying we're going to do something, just like adding and subtracting and multiplying and dividing are things we do. The sine of something and the cosine of something is something that we do. So you need the theta there. So the sine itself isn't an amount. It's a thing to do. All right, so let me continue. Plus cosine theta minus 1 equals 0. And so I'm going to go ahead and distribute that, and I get 2 minus 2 cosine squared theta plus cosine theta minus 1 equals 0. Fantastic. Next thing, let's combine our like terms. So negative 2 cosine squared theta plus cosine theta, and this would be plus 1 equals 0. Now, I never like to factor trinomials when my leading term is a negative. So all I'm going to do is multiply both sides of my equation by negative 1. And that allows me to make this 2 cosine squared theta minus cosine theta minus 1 equals 0. Now, here's where I think a lot of you are getting stuck. Would you agree that this statement right here bears a significant degree of similarity to this? Would you agree? Okay. And we can factor this using slide and divide. So if we do our slide, we have x squared minus x minus 2. And we can factor that, what multiplies to negative 2 and adds to negative 1. So this would be x minus 2x plus 1. And then divide by the 2 that we slid. And this would give us x minus 1. And this right here would be 2x plus 1. Fair enough? So let's slide and divide. You know that. We can do the same thing here. So what we have after we slide and divide this is cosine theta minus 1 and 2 cosine theta plus 1 equals 0. So now I have this times this equals 0, means either this is 0 or this is 0. So I have cosine theta minus 1 equals 0, and I have 2 cosine theta plus 1 equals 0, which means I have cosine theta equals 1, and over here cosine theta equals negative 1/2. Now, don't forget a very important part. I want an expression for what theta is, because my whole job is to solve for theta. So theta equals inverse cosine 1. theta equals inverse cosine negative 1/2. So now you need your unit circle. Let me grab my unit circle right here. Take a look at this. All right, I need, my cosine is an x value. I need where my x values are 1. My x value is 1 right here. So that is at 0 and 2 pi. All right, so theta equals 0 and 2 pi there. Now, cosine, where does it equal negative 1/2? So I need an x value of negative 1/2. And that's right here at 2 pi over 3. And down here at 4 pi over 3. So theta equals 2 pi over 3 and 4 pi over 3. This is that factoring step that I think that you are missing. I mean, this is pretty tricky to switch, because you can't factor this. You can't slide and divide on this, because this is like having y's here and x's here, that you need them all to be the same. But once you get to this point here, you've got to realize that what you've got to do is slide and divide on that and factor it. So let me go over one more with you. Let's go over 47 together. And we've got 2 sine theta plus 1 equals cosecant theta. Here's the deal. There is nothing I can do right now to solve for theta. It would be great if I had all the same trig function here. So I'm going to make this 1 over sine theta. So 2 sine theta plus 1 equals 1 over sine theta. Now, this doesn't help me solve, and I think what will really help me solve is if I can do something similar to what I did in the last problem, which is to get everything on one side and have 0 on the other side. So first I'm going to try and undo this thing here. So multiply both sides by sine theta. And I've got, then when I distribute here, 2 sine squared theta plus sine theta. And over here, these guys cancel and I have 1. Well, we are getting there. Let's move our 1 to this side so we have 0 on the right. So 2 sine squared theta plus sine theta minus 1 equals 0. Let's slide and divide. So if I slide and divide here, let's see, I'll switch colors. Let me grab another color marker here. So I'm going to have sine squared theta plus sine theta minus 2, which is going to give me sine theta plus 2 and sine theta minus 1. Divide both of those by 2, and so I finish up having sine theta plus 1 times 2 sine theta minus 1 equals 0. All right? So I have sine theta plus 1 equals 0, 2 sine theta minus 1 equals 0. This gives me sine theta equals negative 1, which means theta equals inverse sine negative 1. Over here, sine theta equals 1/2. Theta equals inverse sine 1/2. So now, sine is a y value. Where is my y value? Negative 1? Right here, 3 pi over 2. All right, so this is going to give me 3 pi over 2. Over here, I have sine, inverse sine 1/2. I need a y value that is 1/2. So a y value of 1/2 happens at pi over 6 and 5 pi over 6. So this factoring is what's going to get you through this particular section of problems. So if you didn't do too well on that, give these another go. Go back to 45 and 47 that I worked here for you and see where you can go from there.